Assalamualaikum warahmatullahi wabarakatuh and a very good day. Today I will present about electrical protection design foremost. First of all, my name is Ahmad Hisham. Alright, this is a flowchart of electrical distribution system. There are four stages in this flowchart. First of all, this is the first stage which is main switchboard and power factor correction. Next, this is stage 2 is sub switchboard. Stage 3 distribution board. And stage 4 is end user, which is its load. Alright, main switchboard. Main switchboard or MSB is the main element of the power system of any social and industrial facility. The MSB is located in the room or enclosed part of the room where the electrical equipment is placed and accessible only by qualified service person. The MSB is an integrated structure consists of functional elements, namely input panel, partition panel, distribution panel. Both disconnect switches and switches are used as inputs and blocks. Alright, power factor correction is an electrical device used to correct the power factor of the power system. Power factor is measure of the efficiency of the electrical energy used, and it is defined as the ratio of real power to apparent power. Improving the power factor can increase efficiency, reduce energy costs, and reduce stress on the electrical infrastructure. Alright, sub-switch board. Sub-switch board, also known as sub-distribution board or sub-panel, is an important component in electrical distribution system. Used in both residential and commercial building, it acts an intermediary between main distribution board and the final electrical circuit. The function of SSB is distribute electrical power from main panel to various sub-circuits. The SSB also provides additional layer of protection by isolating circuits and containing overloads or short circuit. Alright, now there's distribution board. Distribution board, also known as panel board, breaker panel, or electrical panel, is an essential component of electrical distribution system. It serves as central point where electricity is distributed to various circuits in the building. The function is to distribute electrical power from main supply to various branch circuits, protects circuits from overload and short circuits through circuit breakers and fuses, and allows individual circuits to be isolated for maintenance or in case of fault. Right now, the protection design. First of all, before we can design a protection for the system, we must know the rating current. The rated current, also known as rated current or nominal current, is crucial specification for any electrical device. It represents the maximum continuous current that the device can handle under specified conditions without exceeding the design limits. Okay, for this project, this is the stated rated current for the breaker, the rated current and rated current breaker. Alright, these are the power what's the protection for the project, which is residual current circuit breaker. Residual current circuit breaker is critically safe device in electrical system. It protects against electrical shocks and prevents electrical fires by detecting and interrupting fault current. The function of RCCB are detect ground faults and interrupts the circuit to prevent harm to individuals. Number two, identifies leakage currents that could lead to electrical fires and disconnect the fault circuit. Alright, the other one is miniature current circuit breaker or MCCB. Is also the crucial component in the electrical distribution system designed to protect circuit from overcurrent and short circuit. The function protects electrical circuit from excessive current that can cause overheating and potential fire hazard. Quickly interrupts the electrical flow during a short circuit to prevent damage to the circuit. Right, the MSB protection design, the protection design used to protect the MSB is the MCCB that used above. The MCB rating is based on the rating current of the MSB. If the rating current exceeds 600 ampere, then you can use the air circuit breaker are required. The SSB protection design in the project is the use of MCCB. The MCCB rating are based on the rated current of the SSB. This one is SSB MOS. The rated current is 75.21 ampere and the rated current breaker is 80 ampere. Right now, the DB protection design in the project. In the project, there are 3 DBs available for the design, which is the DB for lighting system, the DB for air conditioner system, and the DB for circuit outlet system. The protection device used to protect DB are MCCB and RCCB. The MCCB and RCCB rating are based on the rating current of the DB. For example, there are 3 DBs: DB lighting, DB aircon, and DB power. The MCCB rating are 32 amperes, 63 amperes, and also the 60 amperes. The RCCB rating is uh 60 amperes with 100 milliamperes sensitivity. Right now, the power factor correction design in the project. There are 5 steps to obtain the design of the power factor correction. Now, step number 1 is calculate the required capacitance value. Step number 2, calculate the new required capacitance based on the rated voltage. Number 3, calculate the minimum required capacitance for the first sequence. Number 4, calculate the required capacitance for the entire sequences. And number 5, retrieve the breaker rating from the total capacitive value. Right, this is the drawings that are used in the project. Okay, this is just MSB drawing. This one is the SSB drawing. This one is the DB for power drawing. This one is DB for air conditioner system drawing. And this one is the DB for lighting drawing. Alright, that's all for me. Thank you very much.
Hello and Assalamualaikum to my fellow lecturers. Today, I would like to explain about the designing a DB and SSB located at office lower floor for assignment 3. First, let me introduce myself. My name is Muhammad Aizad bin Muhammad Fuzi. My matric number is 211092505. So before we start, let me do the introduction for the assignment 3. So what is DB? DB is the main distribution board, is where the main source of electricity is controlled for a large area, residential complex, or commercial facilities like malls, factories, or warehouses. Its main function is to divide the electrical power evenly among all the electrical devices. So next, what is SSB? SSB is an electrical switchboard that distributes electricity from one electrical source to another electrical source. The main purpose of the board is to control the flow of the power. It divides the main current supplied to it into several smaller chunks and distributes it to the devices. So next, we move into the SL table. So, in designing and selecting the molded case circuit breaker, also known as MCCBs, for the distribution board located at the office lower floor, first, we must determine the total connected load, which is TCL for each DB load. The value for total connected load then will be used to find the rated current using the formula given. And the value we get will be increased by 30%. The 30%, which is the new rated current, will determine the selection value for MCCB for each DB load. So as you can see, for DB lighting, the new rated current, which is 21.47 ampere, and we choose the MCCB rating current which is 32 ampere. For dB power, we get 19.87 ampere, and we choose the MCCB rating current, which is 32 ampere also. For dB aircon, we get 55.98 ampere for the new rated current, and the MCCB we choose 63 ampere. So next, how about designing the rating current for RCCB? So in designing and selecting the residual current circuit breaker, which is RCCB, for the distribution board located at the office lower floor, first we must determine the new rated current at each phase from the dB load. To find the new rated current, the concept is same as MCCB, which we must determine the TCL value and increase it by 30% for the rated current. From the new rated current at each phase, we select the highest value to determine the RCCB value rating current. So as you can see from dB lighting, the new rated current, the highest one, which is 12.29 ampere, and we choose the RCCB rating current, which is 25 ampere. For the dB socket, the highest, which is 5.76 ampere, and we choose the RCCB 25 ampere. And the last one, which is dB aircon, the highest one, which is 41.22 new rated current, and we choose the RCCB rating current, which is 63 ampere. So for the last one, we are going to look into the layout plan for the dB and SSB. So this is the lighting dB. The lighting dB is 12 ways TPN and located at billet switch. The total connected load for this dB is 9.73 kilowatt, and the maximum demand is 7.78 kilowatt. So the MCCB for this lighting dB is 32 ampere. The RCCB for red, yellow, blue is 25 ampere, and 100 milliamp for the sensitivity. So for the MCB, the standard for the lighting dB, we choose 6 ampere only. So as you can see from this type of dB, we leave like 3 or more spare circuit for red, yellow, and blue for the future load. So next, for the aircon dB. For the aircon dB, we use 12 ways TPN, also located at billet switch. So total connector load for this type of dB, 25.36 kilowatt. Maximum demand 20.29 kilowatt. So from MSB to MCCB, we select as 63 ampere for the MCCB. So the RCCB for red, yellow, blue, we choose 63 also ampere, and the sensitivity is 100 milliampere. So for the MCB aircon, we usually use 32 ampere. So same as lighting dB, we put the spare circuit for 3 or more red, yellow, and blue for the future load. So for the socket dB, we use 6 ways TPN and also located at billet switch. The total connected load for this dB is 9 kilowatt. The maximum demand is 7.2 kilowatt. For the MCCB, we select 32 ampere based on the SL, and the RCCB for red, yellow, and blue, we select 25 ampere, and the sensitivity which is 100 milliampere. So from the socket we leave for like 3 to 4 spare circuit for red, yellow and blue for the future load. So for the last one, which is the SSB for office lower floor. So this is the layout plan for the office lower floor. So as you can see, the total connected load is 57.32 kilowatt. The maximum demand is 48.72 kilowatt. This type of SSB, we have 5 types for DBs, which is DB for lighting, DB for socket, DB for aircon, and 2 spare DBs. So the DB lighting, we select the MSB rating current, which is 32 ampere. For the DB socket, we choose the MSB rating current, which is 32 ampere. And for the DB aircon, we choose 63 ampere for the MCCB. So for the spare DB, we select the MCCB 63 ampere and 32 ampere. The reason we leave the spare circuit is for the future DBs. So that's all from me, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muklis bin Muhammad Yani. My student ID is 211092514. So now, I will talk about how to design rated current for MCCB in DB for office first floor. In order to design and select the MCCB for office first floor distribution board, the first thing we need to do is we need to find the total connected load for the DB for lighting, socket and aircon. Next, we need to calculate the rated current by using the formula rated current TCL over Z3 times 400 times 0.85. After we calculate the rated current, we need to increase the value up to 30%, and the new rated current value will determine the selection of MCCB for each DB load. Next, in order to design and select the rating current for RCCB for distribution load at the office first floor, we must find the new rated current by using the same method for MCCB, where we need to find the TCL and determine the rated current increase by 30%. From the new rated current for each phase, we will select the highest value to determine the RCCB value. So, this is our DB schematic for lighting in office first floor, and this is our DB schematic for socket in office first floor. Next, I want to talk about the cable selection. As you can see from these schematics, we put a long cable from DB in the switch room to a lamp in the CC room because we need to have the longest cable from the office first floor in order to calculate voltage drop. Next, we also calculate the longest cable for the socket by putting a long cable from the DB in the switch room to a socket in the CC room. After we have the value of the cable length, we can start the calculation for cable selection by using the voltage drop formula. VD equals to VD times IN times L over 1000, which VD is voltage drop from table 4E 4A, IN is breaker current, and L is length of the cable. And finally, we can calculate the percentage of the voltage drop by using the formula percentage VD equals to VD over 400 times 100. Based on this table, as you can see here, we pull out the values of TCL and maximum demand currents we obtained from assignment 3 and select a suitable cable as long as voltage drop percentage do not exceed 4%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazli bin Muhammad Azmi. For assignment 3, mostly I handle the aircon part at floor 1. Now we will describe about the protection system for aircon part at floor 1. These are the example part of the electrical protection system in a building. which MSB, main switchboard, is to distribute electrical power from one central panel to various circuits in a building. MCCB is molded case circuit breaker, is to protect electrical circuit from overload and short circuits handling high current. Next, RCCB, residual current circuit breaker, is to detect and disconnect circuit during earth fault to prevent electrical shocks. And last, MCB, miniature circuit breaker, is to protect small electrical circuits from overloads and short circuit in home and small buildings. Now we continue to the task explanation. For the type of DB, we use three-phase system. We look at this picture, which is it shows the value of MCCB and RCCB selection based on the total connection load and maximum demand value that we are already calculate using several formula and list using Excel. We can get the value of rating current that flow through the MCCB. So from that, we can find the suitable type of MCCB, which is we can use for this condition is 100 ampere, while the RCCB that's suitable with the rating current is also 100 ampere. For the MCB selection, we just follow the JKR specification that's suitable with aircon part, which is 32 ampere. Besides, we use 15 ampere socket to supply the load to the aircon with its type that we are already choose, such as 1 HP, 1.5 HP and 2 HP aircon. We also make a spare circuit for future needs. Lastly, after we calculate the total connection load for the whole part in aircon DB is 44.01 kilowatt and the maximum demand is 35.21 kilowatt. For assignment 4, we need to calculate the appropriate type and size of cable to be used for connecting all electrical protection devices such as the MSB, MCCB, RCCB, and MCB. Using the provided layout, I have sketched a line representing the cable marked in purple, which start from the switch room and extend to the furthest air conditioning unit on the first floor of the building. This line will help determine the length of cable required to supply the load effectively. As a result of the earlier cable sketch, we can calculate the required cable length, which is 60.68 meters. Next, we can calculate the voltage drop in both percent and volts using this formula. However, first we need to determine the total connection load value and maximum demand current to calculate the current rating and subsequently select the type of MCCB. After that, we can determine the suitable size and type of cable so that the voltage drop remains below 4% using the voltage drop formula as shown. For the size and type of cable used for wiring on the first floor, we have decided to use non-armor PVC cable with a diameter of 25 mm. From this selection, the voltage drop for this cable installation is calculated to be 2.73%, which is correspond to 10.92 volts. Next, we can use the same method to calculate the voltage drop from the SSB to the MSB located on the ground floor. For this calculation section, we use a different type of cable, which is non-armor SLPE PVC 70 mm. From this section, the voltage drop is calculated to be 0.13%, equivalent to 0.53 volts. We choose non-armor PVC 25 mm cable for its ease for installation and lightweight properties. As for the non-armor SLPE PVC 70 mm cable, it was selected because of its suitability for high voltage application, as well as its waterproof and crack resistant features, which are highly suitable for supplying the load from the main switchboards. That's all from me. Thank you.
Assalamualaikum and good evening. My name is Muhammad Ali Fakimi bin Muhammad Jeffrey. My metric number is 2110924999. I'm from group 28. Today I will present about calculation cable using Excel. So this is my Excel for wiring system of office, and this is for the most. The cable type that we use is non-armor PVC and armor XLPE/SWA/PVC. There are different types of cable, but these two is commonly used cables in wiring system. First is PVC insulated cable. It used for general purpose electrical wiring in homes, including lighting, power outlets, and appliance connections. It also suitable for a wide range of application in office, factories, and machinery wiring. It also used in vehicles and marine environments due to their flexibility and resistance to chemicals and moisture. Employed in control panels, instrumentation systems and communication networks for reliable signal transmission. Next is XLPE insulated PVC shaded cable. The application is for power distribution. It is used extensively in medium and low voltage power distribution system in residential, commercial and industrial settings. Underground and outdoor installations, it also suitable for underground cable installation and outdoor use where environment protection is critical. It also used for construction. It employed in building construction for power supply, lighting and general wiring needs. SWA, also known as a layer of metal usually made of steel or aluminium that safeguard the internal conductors against physical damage, mechanical stress and environmental hazards. It used primarily in single core. It typically used for underground or external application, offers high tensile strength and resistance to mechanical damage. The cable length for this project decided by the dimension of the building at AutoCAD. Next is cable carrying end. For the cable sizing, IEE wiring regulations require the following conditions to be satisfied. The current rating of the protection device must be equal to or less than the current carrying capacity of the conductor. The design current must be equal to or less than the current rating of the protective device. Lastly, the cable voltage drop. Each cable has their own impedance. When current flow through the cable, there will be a voltage drop within the cables. When the size of the cable is bigger, the impedance of the cable becomes smaller and hence produce lower voltage drop. Based on the requirement of MS IEC 6364552, the voltage drop between the origin of consumer's installation and the equipment shall not be greater than 4% of the nominal voltage. This requirement is there to ensure that the voltage applied to the electrical appliance in the final circuit is maintained within proper limits. In the absence of the consideration, it is recommended that in practice, the voltage drop between the origin of consumer's installation and the equipment shall not be greater than 4% of the nominal voltage of the installation. That's all from me. Thank you.